Okay, in this video, we're going to talk about the properties of logarithms. And again, I'm going to keep stressing to you that a logarithm is an exponent so that sinks in. It's just a different way that we've got to get used to writing it. And the reason why we're going to learn these properties of logarithms is because in the next section, we're going to be solving equations with exponentials and logs in them. And in order to be able to solve those equations, we need to be able to know how we can manipulate these log expressions. So we will use properties of logs to solve equations with exponentials and logs. Okay, so I'm going to go through all the properties with you and give you an example of each. Okay, the first property is called the product rule. And the product rule says if I'm adding two logs that have the same base, I can combine it together in one log using multiplication. So if I have two logs with the same base b, we'll call it log base b of x plus log base b of y. I can combine those together into one log using multiplication. So what would happen is I would multiply the x and the y, and I would keep the same base. So this would become log x times y. Now, because this is addition and multiplication, the order doesn't matter. I could write it as log base b y x, so that's okay. So just keep that in mind when we get into the other rules. Sometimes the order does matter. So an example of this would be if I had log base 2 of 5 plus log base 2 of 7, I could rewrite those two logs together in one log as log base 2 of 35. Because my bases are the same, I can combine those and multiply the 5 and 7 to get a 35 and write it as one log. Okay, the next rule is called the quotient rule. This is where order does matter because this is where it deals with subtraction and division. So with subtraction and division, as you know, the order does matter. So if I have log base b of x and I subtract log base b of y, I can condense that because my bases are the same into one log and write it as x over y. So because my x comes first here and my y comes second, I have to make sure that my order is appropriate and I have to have x over y inside my parentheses when I condense. So whatever comes first with the subtraction needs to go on top with the division. So if I had log base 2 of 5 minus log base 2 of 7, I could rewrite that as log base 2 of 5 over 7. Okay, the next rule is called the power rule. The power rule says if I have a log with base b of x, and that x is being raised to the power, we'll call it r, I can rewrite this by bringing the r, my exponent, down in front as the coefficient of the log. So I can rewrite it as r times log base b of x. So this exponent can come down in front. So for example, if I had log base 10 of 100, I can rewrite that as log base 10 of 10 squared, which I can bring the 2 because this is an exponent for the 10, I can bring that down in front, my power rule, and I can rewrite that as 2 log base 10 of 10. Okay, the next rule is that when I take the log of 1, no matter what my base is, I'm going to get 0. And the reason for that is because if I put this in exponential form, my base is b, my exponent would be 0, I would get out 1. Anything raised to the 0 power, of course, as long as b does not equal 0, anything raised to the 0 power would give me 1. So when I take the log of 1, no matter what the base is, I'm going to get 0. So for example, if I asked you to take log base 1/2 of 1, that should be 0. It doesn't matter what this is, as long as it's not 0. If I take the log of 1, it should always be 0. That's my exponent so that I get an answer of 1. Okay, next rule. If I have log base b and I have b to the r in here, then this is always going to be equal to the exponent if my base and what's inside here for my base is the same. And that is because if I put this in exponential form, my base is b, I raise it to the power of r, and that's equivalent to what's inside my parentheses, so this checks out every time. So if these two are the same, then my answer is going to be r every time. So for example, if I asked you to figure out what log base 5 of 5 to the 10th is without even doing any thinking, because these two are the same, you should automatically say, oh, that's 10. I know that rule. Okay, and same goes for this rule as well. If I have an exponential where I have b raised to a log, so in the exponent, I have a logarithm, and that logarithm is the same base as the base of my exponential, then this is going to be what it's equivalent to. It's always going to be equal to this. So, for example, if I gave you 3 to the power of log base 3, 7, this would be equivalent to 7 because this base and this base are the same. Okay, last rule. This is called change of base. If I'm working with one particular base in logarithms and I wanted to change it to a different base, let's say I was using log base 7, but I don't have that option on my calculator to use log base 7, and I wanted to use the common log base 10, I can change my expression and rewrite it in a way that I do have it written in a base that I can use. So the change of base formula says if I have log base b of x, I can change that to log of any base. We'll call it a, log base a. You can change it to whatever base you want. Log base a of x over log base a of b. So for example, if I had log base 7 of x, and I wanted to change that to an expression so that I could use the log base 10 on my calculator, and I wanted to change that to base 10, so I think of 7 as my base b, And I can rewrite this as log base 10 of x over log base 10 of 7. And then I would be able to use this expression on my calculator because I do have log base 10 on my calculator.